Hello dear students, in this video we'll learn about matrices. We'll start by the definition. A matrix is a m cross n rectangular array of mn real or complex numbers arranged in m horizontal rows and n vertical columns. A matrix is denoted by a capital letter and its entries are denoted by small letters. In this case, it is written in the form of Aij, where I stands for the ith row and J stands for the jth column. So we can see that the first entry is written as A11. That is, it is in the first row and in the first column. Similarly, A12 entry, it corresponds to the first row and second column and so on. Next, we'll define the dimension or order of a matrix A. It is defined as the number of rows and number of columns in the matrix. That is, if a matrix A has m rows and n columns, then its dimension or order is written by m cross n and is read as m by n. For example, here we have a matrix A. It has 2 rows and 2 columns. So, its order is 2 by 2. Similarly, the matrix B has 2 rows and 3 columns, so its order is 2 by 3. Next, we are given type of matrices. We'll start with a square matrix. A square matrix is one in which the number of rows is equal to the number of columns. So, for example, matrix A, it has 2 rows and 2 columns. So, its order is 2 by 2 and it is a square matrix since the number of rows and number of columns is same. Similarly, the matrix B has 3 rows and 3 columns, so it is also a square matrix. Next is a diagonal matrix. It is now a type of a square matrix for which Aij is equal to 0 for I not equal to j. For this, we need to know the principal diagonal of a matrix, generally of a square matrix. That is, the entries on the diagonal, they are usually noted as A11, A22 and A33. So for a diagonal matrix, the diagonal entries can be any, but the off diagonal entries, that is the entries which are not on the diagonal, they must be 0. Next, we have a scalar matrix. It is now a type of a diagonal matrix in which all the diagonal entries need to be same. So, here we have the matrix H in which all the diagonal entries are written as -5. And if all the diagonal entries in a scalar matrix are written as 1, then we call that matrix as a unit or identity matrix. Next is a row matrix or a column matrix. A matrix which has only one row is known as a row matrix, and a matrix which has only one column is known as a column matrix. Next is zero matrix or the null matrix. A matrix in which all the entries are equal to 0 is called a zero matrix. Next, we'll define the equality of matrices. We say a matrix A and B, they are equal if the number of rows in matrix A is equal to the number of rows in matrix B. The number of columns in matrix A is also equal to the number of columns in matrix B, and the corresponding entries in both the matrices, they are equal. For this, we'll take an example. Here the matrix A has order 2 by 1, that is, it has 2 rows and 1 column. Similarly, the matrix B has also order 2 cross 1. So, the number of rows in A and B are same, the number of columns in A and B are also same. So, to find the value of X and Y, we need to equate the corresponding entries, that is, the A11 entry is equated to the A11 entry in the matrix B. Similarly, the A21 entry in matrix A is equated to the A21 entry in matrix B. We'll get two equations in X and Y which can be easily solved to get the values of x and y. Next is the transpose of a matrix. By the transpose of a matrix, we simply mean to interchange the rows and columns of a given matrix. So, for example, we are given a matrix A. Its first row is -3, 2, 5. We'll change it into the first column, and its second row 0, 7, 8 is also changed into the second column. So, this is the transpose of a matrix A and is denoted by A dash. Here again we have a special type of matrices, square matrices. They are said to be symmetric matrices if the transpose of A is same as the matrix A, and it is said to be skew symmetric matrix if its transpose is equal to -A. So now you can solve the questions given in this topic and check your progress also. So happy learning to you.